Hi, I'm Elton Hunter from SPI Inspections. I'm the field manager for our Alberta team. We're out today at a 500,000 volt substation. This is a 500,000 volt AC to 500,000 volts DC switching station, and then an inverter station to 500 volt DC. Beautiful sunny day in July, and it was a hot day, probably around 27, 28 degrees. On first unboxing, Travis had sent the instructions to us, but we didn't find them until actually we decided we sent it back 2 weeks later. So is this instrument easy to use? Absolutely. We picked it up. We'd watched the video. We are pretty comfortable with techie type tools like this. We went over the instructions that we could get with it, and we used it. Now, we understand that this tool is not primarily designed to do what we were doing with it, but it is exceptionally good at finding corona and corona discharge at medium and long range distances. On the initial usage of it, very easy to turn on, to get calibrated, to put the date in it. The battery is a little bit large. It took us a while. We figured that the best thing to do is to put it in a little backpack. Our plan was to use it for a full day here on this site. We had access to the largest substation in Alberta, and we were getting comfortable with the equipment. We had both the Si124 and the GS77 going at the same time, so we were able to look in full spectrum. We're using the IR camera of the GS77 and, of course, the Si124 looking for corona. Our customer had identified to us that they had a bit of a problem, but they didn't know where it was coming from. So this is Rick Patry holding the camera, and Brett Fleming, he's looking through the IR camera, and we're just doing an initial walk around. This tower is 220 feet to the top phase. It's a steel tower. The line is 5 years old, so relatively new. The Q&A was done on it, and it was all finished off and checked 5 years ago, so it should be in fairly good shape, yet we were still concerned that there was some initial problems. So let's put some things in perspective with where we're working. This line is about 1,200 structures, and we went out to structure number 1, and the lowest conductor that we can get to here is about 160 feet from the ground. Initially, when we took the camera out, we weren't sure how long it was going to last. We use inverters. So we have a DC 12-volt battery that goes into our inverter. It then produces 120 on a square sine wave. We were also a little concerned how long the battery would last us in the field, and I can assure you that we went all day. This was an 8-hour day. We used it all day long. No problems with the battery whatsoever. Even the recharging, you can see here, I've got a 12-volt battery that goes directly to our inverter. There was no issues with it whatsoever. It was very easy to charge and rectify. Our trucks that we use are set up very well. They have a 3450 inverter in it, and it's very user-friendly, very easy to work with. Here you can see Rick and Brett are setting the time and date, and on our initial run through on it, we're just setting it up for ourselves. Of course, we hadn't operated it before, and Travis hadn't given us any instructions or anything. So it is very user-friendly to calibrate and get set up and to use. And in full sunlight, we had a very sunshiny day, and it's very easy to use as well. Here you can see Rick. He's getting a bit of a feel for the camera, and we had picked up something. We weren't sure what it was. With corona, it produces a high voltage emission when there's a sharp wire or a sharp point or damage to the wire or some damage that's not designed. And what we're trying to do is figure out what's going on. We initially picked up a small hotspot. We couldn't figure out what it was. By having a second camera, we actually had a full spectrum zoom lens. It had a 50 power zoom lens. And we were able to pick up this small split that you can see in the corona ring. So corona ring is installed on a power line to reduce the corona, and obviously that produces ozone and causes a large static buzz, and is particularly noisy on the AM radio frequency, and it was able to pick it up. We had to take some pictures, zoom them in, and we initially found out what it was. You can see here in this photo where there's water got into this corona protection device and froze over time and split. And that's initially where the Si124 pick it up and indicate that there was going to be a bit of a problem there. Now you can see Brett's using it. Brett is looking up, and you'll see Rick is taking notes. One of the key things that we find is taking notes on everything we do. You can take far too many photos and it ends up just a big mess. We take photos and record them, time and date and place. We're fortunate with the Si124 and the GS77 that when you take a photo, it gives you an identifier of where that photo was taken on GPS, so we know exactly where it was done. But we still take notes of what we're seeing, and we identify when we take pictures with the camera. So when you take pictures with this camera and it tells you that you're on picture 65, we then mark that in our notes, and when we go back to convert the photos and what we've gathered in the field to our report, it makes it much easier for our staff in our office to put it together so it makes sense, much like this, to send a report back to our customer. This is standing on the ground surface level. We're looking up, and this is the top phase on the east side, and it's about 220 feet from the ground level. We're looking up with the Si124, and we could see a very distinct red hotspot. It was indicating there was a corona issue. So it gives you some indication of how tall these structures are. There's a couple settings for the camera. This is on the farthest one. And you can see from ground level, without some assistance, you cannot tell anything. You can't see anything. This is one of the corona rings on the corner. This is the exact one we're looking at. On initial look here, you can't see anything. Everything appears to be correct. The jumper glass that goes around is intact. All the hardware looks to be in good shape, and you cannot see anything wrong with the initial dead end bells. They seem to be good. Now, if you look here closely, you'll see what we see. The camera itself is indicating that we have a hotspot. Now, on first go around, we couldn't pick it up. We all have over 30 years of experience. Rick is especially good at this type of Q&A. This tower is well within his spectrum of work. He did this exact work for the previous 15 years, and he did a lot of Q&A on this particular voltage and type of construction. What you can see here is Brett is holding it, and just to make sure that it's not easier for one guy or another, he went in, picked it up, and he was able to pick it up exactly as easy as what Rick did. So you can see on the controls here that we've got it all set up. We're taking notes on what setting it's on, where it's taken, time and date, and we're starting to put together a scenario of what's going on or what we found out here. We've moved from that job site into the inverter station. So this is the largest substation in Alberta. It's 500,000 volts AC in to 500,000 volts DC out. And we're taking high resolution, full spectrum photos as well with the Si124. We're going around, and we were invited into this substation by the substation lead. He's the foreman out there. And the substation is only 5 years old, so it's a very well maintained substation. They didn't suspect there would be any issues out there. In the initial walk around, he said, tell us what you think, see what you can come up with. We would be curious to see what this camera can do. And of course, it was a bit of a learning curve for us. So we also wanted to take and go in blind, as it were, and see what we could find. This is the bus work as you walk around inside the substation, and we're looking at a suspension joint. So this is 500,000 volts AC coming in, and we're about 40 feet in the air to the connection joint here, and this is called an expansion joint. And we picked up a hotspot on this one, and we didn't know what it was. Now, obviously, there's going to be some noise inside a substation, but this was a particularly noisy one. So we identified it for our customer, And generally, as a rule, when we find that we have a hot spot in here, it's due to tension on the joint or some change in the physical structure. These are helical screw piles. They're called PISAs, power installed screw piles that go down into the earth. And what happens is over time, frost tips them one way or another, and it causes some stress on there. And that's what this camera was pointing out here. What we've done here is we've moved over and we're showing you how the camera itself is easy to use. So this is the interface, this is the keyboard. And even with our big construction mitts that we've got on our big hands that we have, we can identify the structure, which the utility has identification numbers on each one of them. And we're looking at specific things, and we can type in notes, hotspot, corona coming off on which joint, and it's very user-friendly. We found that using it in the field was very easy to identify the structures we're working on and the plant, which is what the utility calls the equipment we're working on. The plant, we could take and label it and make it really nice and clear for ourselves when we're sending in our report, and for them as well. We really did put the Si124 through its initial paces. What we're doing here is there's a chain link fence inside the substation that limits access. This is a 500,000 volt AC series parallel capacitor bank. And just because of the limits of approach, you don't want people walking in this particular area. So we walked up and we looked over the fence, thinking the chain link fence would be an impediment to what we were doing. And we had a bit of a hot spot here. So we walked up, and it's an 8-foot fence. We reached up and we looked over it. We could see it nice and clear. And we thought we would have to take and do that. You can actually see here where Rick has walked right up to the fence and is actually just looking through one of the 2-inch squares. And if you look closely on the screen, you can actually see that we are looking right through the chain link fence with the initial camera on the 124. And of course, it's listening through the chain link mesh. And at this voltage, it's very accurate. We looked over it. We can see exactly what we were seeing looking above the fence as well. And if you step half an inch to one way or another, it would interfere. So we didn't even have to enter this area, which is obviously more dangerous for our personnel or any personnel that's in there. And if we used it properly, we could use it without accessing or getting within the limits of approach. So I took a picture here of Rick, and you can see from my perspective what he's looking through. Immediately behind him is one of the towers for the 500,000 volt capacitor bank, and we found a hot spot right inside the initial tower, and we wanted to document it. You can see the perspective on the right hand side. This is a huge substation. From where I'm standing, you can walk 450 to 500 meters and still be inside the substation. Now, this is the internal bus work, and these structures are 60 feet in the air. So we have to have a minimum of 27 feet of clearance. So you can see the size and scale of this substation. This is just initial bus work, and we found a hot spot. We couldn't figure out why. This bus work is 4-inch solid aluminum, and they have voltage connectors on the joints. And the corona ring, you can see the corona ring on the top of the porcelain, and should have been quiet. We could not observe anything that was visible in full spectrum, yet the Si124 was very adamant that there was an issue or corona coming off there. So we documented it, and you can see a picture of it. We're looking up at that same structure as in the previous picture, and we're identifying a hotspot. We're typing in the structure number, the time and date. We took photographs and we included them in our report to our customer and indicated what we had found. Right here, you can actually see the bus work that we were looking at. You can see a bit of a hot spot. Now, this is one structure over, and we couldn't initially figure out what was going on. There was obviously some corona discharge there, very visible to see in the screen. That's the one nice thing. It's a nice bright screen, and in full daylight, you can see crystal clear on it. So we documented it, and we'll keep that for reference for future. We couldn't find anything wrong with it, but what we'll do is we'll come back in the future and we'll check the same spot again, and then we'll know if it's getting better or getting worse. So this is what we see when we're looking up at it. We're looking directly at the structure. Couldn't find anything other than above the corona ring. One nice thing is you don't have to worry about sun blindness with this device. It was a nice bright sunshiny day with some nice fluffy clouds in the background. And from no matter what angle we were at, we didn't have to worry about the sun being an issue when we were looking at specific items. Sometimes that can be problematic in a substation like this because you can't get in a perfect angle on them. So that was sort of nice, a user-friendly feature of this one. We've moved over in this one here, and we're in a 250,000 volt substation. And we're looking at the what we call the secondary side. So this is 250,000 volts. And we have a cutout here, a switch. Very easy to point out a corona incident here. They have all kinds of wildlife defenders on the arresters here, but we found a corona hotspot. Now, that could have been something as simple as a small piece of wire where the connection is here. We believe that's what it is. Even just a small piece of wire sticking off will throw corona off at this voltage. And although we're getting a really nice hotspot in a picture, the device number was documented and it can be fixed over time. CRTC, radio and television communication people, don't allow corona incidents like this to continue. If it can be fixed, you should get in and get it fixed. We identified it. And on the next preventative maintenance or shutdown they can go in and they can try and correct that with no extra cost to themselves. And they know exactly where to look. This is a 250,000 volt SF6 breaker. And we're looking at the top of it here. When we initially went in there is an issue with this breaker. It had been worked on previously by the substation people. They come in, they were a little skeptical about what we were doing and the equipment we had. And they said, yeah, we've got some problems in here. We suspect we know what it is. You guys tell us what it is. And we were able to walk in the first 5 minutes and very crystal clear some issues. We were able to document them and pinpoint them in our report. You'll see how we do that. This is a 250,000 volt substation. And this is a disconnect. So it's not designed to be a load break disconnect. And you can see there's 3 of them here, but we've got a hotspot on one. That's a bit of a concern. If you're going to have a hotspot, you should have it on all 3. In this particular case, having one there indicates that there's either the jaws are not perfectly aligned or there's a bit of a gap there and causing a little bit of a static discharge. It's super easy to see. It was a little bit more cloudy on this particular day. There's a high overcast with cumulus clouds mixed in. And when we use the IR camera, you can see that it stuck right out. So this switch here, we documented, and the next time they do a PM on it, they'll spend a little bit more time possibly on this phase and try and figure out where the corona is coming from. This is a brand new 250,000 volt switch, and we're seeing corona discharge on each one of the switches. That's not necessarily a bad thing. On these ones, they have a bit of an arcing horn, and it has a bit of a sharp piece of metal sticking out the top. When it opens up, it tries to discharge through that so it doesn't deteriorate the contacts. In this particular case, we would not make any recommendations to the customer other than document it, give them a full color photo, give them the FLIR photo from the Si124 here, and do a thermal scan as well, and indicate that this was a normal condition on this particular day, wasn't excessively noisy, but we just thought it'd be a good opportunity for us to identify the camera that it is working correctly. This is exactly what we do when we hand it back. This was a problem for the utility. They had several reports of a noisy transmission line or a noisy distribution line. This is a 25,000 volt Y system. In here, you can actually see on the right-hand side a full spectrum photo of the structure, a street light on the bottom, an underground dip hole going up to the 3-phase. The 124 is the photo on the left-hand side at the top. It indicated that there was a noise issue up there. We looked at it from 2 or 3 different angles. We used the full spectrum. We used binoculars. And the only thing we could come up with was a noisy tie or cracked insulator. This is the report that we do up when we give to our customer. This one's redacted, so it's blacked out. And what we did was to indicate everything we did on this. We also took an IR picture, which was actually done through the Si77 down below on the left-hand side there. And we put our recommendations in for what we found and how it could be fixed. The nice thing about the Si124 is there's a couple modes that you can use it in. And the one we were using it in here was in the 30-meter mode. So we could actually just drive down the road with the camera and hold it out the window. And the operator who's sitting on the passenger side could look up and we could pick up hotspots. In this particular one, there's the full spectrum picture. It's sort of gray and sort of an overcast day. But if you look at the photo on the right-hand side, you can actually see the corona incident. And this is on 120 volts. So this is a much lower voltage. And it's very clear that we had a hit here. So we put in a recommendation for radio noise detection on that particular secondary circuit, which was a bit of a surprise for us. We weren't sure it would pick up something that small. The level of the interference, we did take a thermal image on as well. There was no thermal footprint that we could see. And the solution was very quick and easy, just to replace the neutral. In this picture, you can actually see a very close up of the connection. So this is a small neutral connection. It's about the size of a quarter. It's just an aluminum ACSR triplex neutral connecting to another triplex. And we were able to sort of whittle it down to that little connection, which is an easy fix. It can be fixed relatively inexpensive. You just put on a second squeeze on, clamp it down. And the reason we believe it was noisy was because the wires had been squashed and they'd separated a little bit. And the camera identified that immediately. It was very easy for us to pick up on it and identify what needed to be fixed. So for our customer, this was a huge problem that they hadn't been able to find for years. And within minutes, we were able to identify it for them. This is about 15 structures down. It's on a intersection where it goes from a 3-phase intersection to a single phase below, and we picked up an immediate hotspot. Now, this is a cutout on the right-hand side, and the cutout has a piece of copper that goes into the bottom of the cutout, and it then goes out and there's a squeeze on. That's there because of the differences in thermal coefficients between copper and aluminum. And the cold flow, the procedure by which something is put under pressure. Now, cold flow for aluminum, think of your hand with a small gob of mud in it. When you squeeze it tight, the mud comes squirting out between your fingers while it's under pressure. The same thing happens with aluminum. Copper isn't so bad. Copper is actually much more resilient. It's a very tough metal, and that's why we use it on the cutouts. This one here, we could see that the bolt, the copper had been passed through the connector out the other side, and there was a little bit of copper that was not clamped down, and it sort of opened up a little bit. And when we looked in the Si124 lens finder, it come out as a clear hotspot. So again, it's one of those things where you wouldn't normally catch it, and it was producing a lot of radio noise in this particular community. The AM radio station is way down on the bottom end, and it's particularly noisy corner, and complaints have been made to the power company that when they drove around in that area, their radios would be all staticky. Well, this was a very easy one to pick out. You can see in the bottom left-hand corner photo, we use the IR, and obviously there's no hot spot here. It was not hot because of current going through it. It was just the corona issue that we found with the Si124. So again, very easy for us to pick out, very user-friendly, easy to document, and because of our background in this type of line hardware, we were able to identify it, make a recommendation to our customer, and then they could take and go and do a corrective action on it and improve their system so that it was not interfering with the FM or AM spectrum in that particular community. So if you have any questions, this is the kind of information you can gather with it on the power system. We were very surprised to find it and to use it, and it was very user-friendly for us, documenting in full spectrum, IR, and in the corona. It was very easy to do on the initial operation that we did. We were very impressed with it, and for the cost of the camera, we thought it would be a nice addition to our company in that this is the kind of stuff that our customers are looking for all the time. Great value for it, and we'll be buying many more of them. I want to thank Travis and FLIR for sending it out to us, and we hope this makes it easier for you to pass on to your customers. If you have any more questions, please don't hesitate to give us a call. at spiinspections.com. We'll leave our website at the bottom here, or contact Travis. And if he thinks that we can help out, he can forward you on our contact information.